The difficulty in computing arc length has everything to do with evaluating the integral, in particular getting the antiderivative. Speed calculations, on the other hand, are straightforward. Here we want the speed of the curve 3 sine 5t, 8 cosine 5t at time pi over 4. Of course, this is x of t, this is y of t. We can just go ahead and compute speed. That's the integrand in the arc length formula, so it's root x prime of t squared plus y prime of t squared. X prime is 3 times cosine 5t times 5, square that. And y prime is 8 times minus sine 5t times 5, square that. And I'm interested in the speed when t is pi over 4. Okay. So I can see I'm going to need to know what is the cosine of 5 pi over 4, what is the sine of 5 pi over 4, unit circle to remind myself 5 pi over 4 is the angle here. So cosine will be minus root 2 over 2, and the sine 2 will be minus root 2 over 2. Plug these in. I get 3 times minus root 2 over 2 times 5. Square that. I'll have 8 times, becomes a plus root 2 over 2 times 5. Square that. Three and 5 gives 15, so it's 15 halves squared. This will be 8 times 5, which is 40. Times root 2 over 2, square that. Simplifies to 1825 over 2. Looked that up. Of course, also be mindful of units. Speed will have units of meters per second.